In the receipt message and tip amount experiment, we had 3 separate groups: the good weather message, the bad weather message, and then no message. So if we look at every possible way that we can pair these groups up, we'll get 3 pairings: good weather versus bad weather, good weather versus no message, and then bad weather versus no message. So we have 3 possible scenarios to look at, and what we're going to do is we're going to apply the 2-sample t-test to each of these scenarios. The reason we're using the 2-sample t-test is that each of these groups is completely separate and independent from each other. We have one group of people who got the good weather message. We have totally different people who got the bad weather message. And then we have still even more different people who got the no message. So there's no overlap between these groups. All right, so one of the first things we do in a hypothesis test is look at the hypotheses. So a null hypothesis in a 2-sample t-test is that the mean of one group is roughly equal to the mean of the other group. And the alternative hypothesis is that the mean of one group is either less than, greater than, or not equal to the mean of the other group. So what I'd like you to do is to imagine that you are the lead researcher, and I want you to decide how you would set the alternative hypothesis for each of these pairings. So either a less than, a greater than, or a not equal to. And don't worry about whether you have the same answer as I have, probably based on experience. If you've worked in the restaurant industry or you've looked at data on tipping, you might have a different opinion than someone else, and that's totally fine. This is just your best guess at how you would set those alternate hypotheses. All right, so I'm going to go ahead and show you kind of what I settled on. For good weather versus bad weather, I figured probably people might tip a little bit better for a good weather message. So I put the good weather mean is greater than the bad weather mean. For good weather versus no message, that one's a little trickier. I finally settled on good weather, probably the mean is bigger than the mean for the no message. But if you had something different, that's totally fine. Again, this is really just based on your experience. And honestly, that's how any researcher sets their alternative hypothesis. It's their experience in that field, working with that information and those species and that data. That gives them an intuition for how to set that. And then bad weather versus no message. I thought bad weather, probably that average tip amount is going to be less. So I have bad weather is less than no message. All right, so that's a little bit about how the hypotheses work. We're going to take a look at that a little bit more closely in just a couple of videos. So don't stress too much about this quite yet. Before we move into how to do the 2-sample t-test, I do want to take a look at these graphs a little bit. So we're going to start by looking at the normal probability plot and just do a little bit review on that. So remember, on a normal probability plot, we're looking for the data to form mostly a fairly straight line. It can be a little bit bumpy. A little bit of outliers are okay. We are looking for that straight line. So for all 3 of these normal probability plots, they do make a fairly straight line, but they are all also slightly skewed. So what I'd like you to do is, between either the normal probability plots or the box plots, I want you to go ahead and pause the video and decide, do you think that that particular group is more left skewed or right skewed? All right, so we're going to start with the good weather one, and I think it's a little bit easier to tell the skew direction from a box plot than from the normal probability plot. So in the good weather one, I see that that upper whisker is quite a bit longer than the lower whisker, and the mean is just a tiny bit higher than the median. So remember, the mean is that X and the median is the line that splits the box into 2 pieces. So because of that, I would say that the good weather one is slightly right skewed. Not terribly, but just a little bit, and that's fine. A slight skew is okay to do these processes with. For the bad weather one, I'm looking at how that box was split into 2 pieces, and the top part of the box is really small. The bottom part of the box is longer, and then we also have 2 outliers down below. So I would call this one kind of slightly left skewed because the lower end is the part that's getting dragged out. Then the no message one definitely is left skewed. Here we see a number of outliers on the lower side, The mean is also quite a bit lower than the median. The mean is almost down at Q1. So that one is definitely going to be left skewed. Okay, and then one last thing, I would like you to go through and let's estimate what these means are. So the mean is the X. When I look at the good weather one, I'm going to see maybe about 22 or 23. The bad weather one, the one in the middle, it looks like the mean is maybe about 18. And then for no message, that mean is, I don't know, maybe 18 or 19. So somewhere in there, again, we're just ballparking it. We can definitely get the exact value from our data set, but just kind of ballparking and looking at these, if I had to decide which of the pairs is going to be statistically significant, meaning that there's a big enough difference between their means, if I look at the X for good weather and bad weather, that seems like a pretty big difference there. So I would say that pair is probably going to be statistically significantly different. If I look at good weather versus no message, again, that one does look quite a bit lower. So I would say that one's probably statistically significant. But if I compare the middle and the last graph, the bad weather and the no message, those X's look really, really close. So I would be surprised if we got a statistically significant difference between those two when we go to apply our two-sample t-test. All right, come back in the next video and we'll look at the two-sample t-test for all three of these pairs.